Hello, everybody. My name is Mirko Novakovic. I am co-founder and CEO of Dash0, and welcome to Code Red. Code, because we are talking about code, and Red stands for requests, errors, and duration, the core metrics of observability. On this podcast, you will hear from leaders around our industry about what they are building, what's next in observability, and what you can do today to avoid your next outage. Today, my guest is Frederic Branczyk. Frederic is the founder and CEO of Polar Signals. Before Polar Signals, he was a senior principal engineer and observability architect at Red Hat via the Core as acquisition, and the Prometheus and Thanos maintainer and the tech lead of Kubernetes Special Interest Group Instrumentation. So, Frederic, welcome to Code Red.
Thanks for having me.
And as always, I always start with my first question is, what was your biggest Code Red moment in your career? Essentially, did you have ever a situation where you had to troubleshoot and you were looking for the right tools to help you?
Yeah, I think there's one particularly severe one that still haunts me from time to time. We were operating this kind of telemetry pipeline. Basically, tons of telemetry was ingested in this, and Thanos was the backend for this. And the difficult thing was essentially that we got into this kind of situation where the component that was accepting writes kept crash looping, and then it wasn't able to replay from the write ahead log. And so every time it tried to replay from the write ahead log, it crashed again. And so it's just like kind of a cascading mess. And I suppose in a way, that's where Polar Signals manifested itself, because we didn't really understand why this was happening. Right? I don't know that I realized it at the time, but profiling was definitely the right tool to fix that and to understand deeply why that was happening and how we could have solved it. But yeah, that's an incident that still haunts me.
Yeah, and we will talk more about profilers, right? Because also, as we heard, very technical crash loop things, recovery, that's database stuff, right? I mean, you are a database developer, and that's a world where you also cannot work with normal application type of tools, right? Because it's different latency patterns and tracing does not really work. So that's where profiling shines, but we will talk about that. But I will start with a big announcement that we want to make, right? By saying that we joined forces, and actually Dash0 is announcing that we are acquiring Polar Signals. Yeah, and we joined forces to build the best observability and monitoring platform on this planet, and profiling will be a big pillar of that. So
thank you. Yeah, super, like, really excited about what we can do together with the profiler, but also where we can take the entire platform. I think there are a lot of super complementary things between Polar Signals and Dash0, and yeah, I'm really excited.
Yeah, absolutely. And then we can talk about it. Why I actually started my career essentially as a profiler trainer. I think I told you with Quest Software JProbe, and then JProfiler by EJ Technologies out of Munich. And I did trainings, and so I'm a big profiler fan. But at the time, I have to say that was not continuous profiling in production. That was profiling on a single laptop or computer for a developer, right? And you were never allowed to really put that into production because the overhead was just too big to monitor something in production. So we will talk about what continuous profiling is compared to, I would say, traditional profiling on your machine. But let's talk about how this all started, right? We knew each other before. I mean, we shared booths next to each other at KubeCon and had some discussions at these shows. And then we met at a dinner in Berlin. And we sat next to each other by accident. And we figured out that it makes sense to join forces, right? We were in planning to build a profiling tool. And we will also talk about database. I told you about our, I wouldn't say issues, but challenges with our ClickHouse database in terms of scale, performance, cost. And you were telling me that I think you already did the 5th iteration of your database backend. And so we figured out that you essentially had the backend that we wanted to build. So let's start with that. Why did you build a database? I think when we first met, I said, oh, That's not a good idea to build a database, right? Why would you do that?
Part of the answer has to be because we're also a little crazy.
It's true.
But no, you mentioned it at the very start. So for the last 10 years now, I've been a maintainer of the Prometheus project. In Prometheus, for those who maybe aren't familiar, time series are tagged with arbitrary key value pairs, right? And it's kind of up to the user and the organization to create the data model however they want it to be, right? Like they can attach whatever labels they want to, filter by them afterwards, query by them, and so on. And I personally think this is one of the key reasons why Prometheus got so popular. It didn't force a way of how to use the tool onto the users. The users could project the way that their organization works onto the tool. And so this was always a very core thing that we felt very strongly about at Polar Signals, that this is the kind of experience that we needed to provide for profiling as well. More generally, for all observability. And one of the things that we quite quickly realized, right, like in the Prometheus ecosystem, if people have operated Prometheus, they're probably quite familiar with cardinality explosions, right? Which is when you have a label value that changes frequently. Like a common kind of mistake that people make is that they accidentally add the user ID or a request ID or something into one of these labels. And that's fundamentally not how Prometheus is supposed to be used. And in Prometheus, it then creates a bunch of issues. But with profiling data, it's very naturally unlimited cardinality. Every sample that you see is essentially unique, but you still want to be able to search for and aggregate by all dimensions arbitrarily. And so that eventually, after a couple of iterations, landed us on at least a columnar database. And well, at the time, there were a couple of things in the works by a couple of companies that could have fit the bill, but they were either not available to us or commercially unviable for us. The way we always thought about it is that every key that we see appear in the data set should become its own column, like a full column that we can query by, filter by, aggregate by, right? And there was simply no database on the market that could give us this. There were like a couple of things that Snowflake have done that were really interesting, but I don't think we could have built a business on Snowflake in that way. Maybe we could have starting out with, but certainly long term we wouldn't have been able to do that. Basically, in order for us to deliver the experience that we wanted to our customers, we had to build this database.
Yeah, makes sense. And so why 5 iterations?
Well, the short answer is because we got it wrong 4 times.
And I hear that all the time, right? You hear that from everyone. You know that I think Datadog released blocks why they had 4 or 5 iterations of the database, right? It seems like a normal pattern that you get it wrong first time and then you need to iterate. One of the reasons why we said maybe we don't do that, right? And we work with someone who has already done that because we don't want to get to all those 5 iterations. So what's getting wrong, right?
I think, I'm sure you can relate to this as a founder as well. There's like a certain amount of naivety that you need to tackle these kinds of problems, right? Like you kind of need to not realize how hard it's going to be. And so, we kind of just went head first and tried our first 2 iterations, never saw the light of day. Like they kind of died in MVP status. And then really, what was somewhere between our 3rd and 4th iteration, what we ended up calling FrostDB at the time, was certainly a spiritual predecessor to what we now call Great Lakes, which is, it was a database written in Go. It was already columnar, and it was based on Parquet. It was based on Apache Arrow. So a lot of the fundamental technologies that we ended up with in our latest iteration, Great Lakes, were already there. We kind of painted ourselves into a corner, right? Like we did a couple of decisions, and it would have been very difficult for us to kind of evolve that system further. So a couple years ago, we kind of made the decision that we were like, okay, we're gonna start from scratch one more time, and we're we're going to learn one more time from all of this, and we're going to get it right this time. And it turns out, well, fingers crossed. So far, it looks like that final iteration is actually working out really well. So yeah, that's kind of the very, very quick history of our databases.
Yeah, makes sense. And let's talk a little bit about profiling, right? The profiles that you are storing there and why there are so many, and what the difference is between continuous profiling and normal profiling. Tell us a little bit, what is profiling?
Yeah, so profiling is essentially a kind of dynamic analysis of your running programs. So basically, there are kind of two large areas of profiling that people call tracing profiling, which is essentially that you truly, literally trace absolutely everything that happens in a process. And this is often what people associate also with profiling when you say profiling. And this can genuinely only be done with pretty high overhead. And then there is another set of profilers that we call sampling profilers. And these essentially, quote unquote, only look at what is my program currently doing, 100 times a second or something like that. And it turns out, doing it 100 times a second per CPU core or something like that still gives you enough statistics that, it actually represents the real world, but it's far cheaper to collect and produce this data. And so continuous profiling, both means that you have profiling always on in production, and that we use sampling profilers to obtain this data.
Yeah, I always described it. I just had to Google the English word. It's called flipbook. Daumenkino in Germany, right? When you draw these pictures, maybe as a kid we have done this, right? You draw a picture and you draw 10, 15 pictures, and then they use it and you flip them, and then it looks like a small video, right? Because the things I think profiling on this sampling approach is very similar, right? You look at the stack that's currently in happening, and then you do that, as you said, maybe 100 times a second, which is, by the way, similar what you do in movies, right? And then you create what happened looking at those stacks, right? So I remember when in Java you had always this stack view, right? And you see what's the current method on the stack, then you see the next method on the stack, the next. Yes, you can miss if you have 100 times per second. Yes, you have a granularity. If something is faster than your sampling rate, you will miss that. But that's also probably so fast that it's not that important, right? But if something is really slow, it will stick and you will see it, right? So that's essentially how it works, right? And those things can, I think, depending on the programming language, can be taken very quickly without a lot of overhead, right? And I think you are using eBPF for that.
Correct.
Which essentially means, at least from my understanding, but you can correct me if I'm wrong, I don't even have to stop the process, right? Or do I?
I mean, there are a lot of ways to implement profilers, but the way that we went is we essentially tell the Linux kernel that on a per CPU core basis, every X amount of CPU cycles, insert our eBPF program. Okay. And so we don't need to stop the world, because it kind of just happens as the processor cycles happen anyways, right? And what we just do is, we can then, exactly like you said, we look at what is the operating system stack like. This function calls this function, calls this function, calls this function, and therefore we know, what the full function call stack is. That's ultimately what a profiling sample is. We send that off to Polar Signals Cloud, and there it can be analyzed.
And that's what you have to store, right? You essentially have to store these stacks with the full method level stack, right? And if you create 100 per second, you have to store a lot of them.
Yes.
That's essentially why you use that database, right?
Yes, exactly.
Interesting.
And I think this is also one of those things, now that we've talked a little bit about what profiling data actually looks like, because we own the entire pipeline down to the storage layer, we can actually optimize this in ways that, off-the-shelf databases would never allow us to do that.
Yeah, give us an example.
Yeah, well, this is a great example. The stack trace, right? Like what kind of data type do you use for a list that is deeply stacked?
Blob.
Yeah, exactly. As a matter of fact, that was one of our iterations of storing this. But there are a couple of things that we can do, right, where we can kind of exploit what this type of data looks like. And the reality is, for most processes that are server processes, they tend to do largely the same stuff, right? So like we can do a lot of deduplication of stacks. We can also do something called symbolization. So like there are for like languages that are compiled, like Go, C++, Rust. These kind of languages that produce binaries, they also produce something called dwarf or debug info. And this is essentially what allows us to translate memory addresses, which is really the result of the stack unwinding process, to translate these memory addresses to human readable function names. Okay. And again, we don't actually need to store the function name, millions of times over and over and over. We actually do this lookup at query time. And once again, because we own the entire layer, we can actually deeply integrate the symbolization process deeply into the database, and therefore make it much faster than if we were to do it after reading the data out of the database, for example.
Yeah, and I can relate to that. I remember, as I said, ages ago, when I was doing profiling in the Java space, I remember these stacks. The first 90% always looked almost the same, right? Because you had the whole infrastructure of your WebSphere, JBoss, whatever in there, right? The servlet calls, etc. And then down there, you had your application calls or frameworks, etc. But the first part, you always looked at it, you totally understood, okay, this is like as always, but I can see how you can really compress and deduplicate that pretty hardly, right? Yeah, absolutely. Yeah. But that also means, because you are using eBPF, you can profile anything, right? Including Rust and compiled languages, right? C++, which Correct. Is really important if you want to profile, I would say, infrastructure technology like databases, right?
Exactly. Yeah. I mean, it's like if you looked at our like landing page, it was no secret that high performance software is where we found a lot of use for our product. Whether it's databases, like TurboPuffer, a lot of the new databases, all a lot of them use our product. So yeah, it's definitely very, very effective for those use cases.
But interesting enough, they use it to highly optimize their infrastructure, right? Where Correct. I think profiling has so much potential in normal applications, because there is so much low-hanging fruits in normal application that get deployed. And something to remind, profiling is not only about performance, right? Response time is essentially also optimizing CPU and memory usage, right? So that means you just consume, because something can be at the same speed, same response time, but consume much less CPU, which at the end means you can run more of the same on a CPU. So you need less infrastructure, right? Which translate into cost, right? Yeah. If I run a huge infrastructure, if I'm a large customer and I have maybe thousands of CPUs I deploy in the cloud, if I can reduce that by half, I only pay half of my EC2 bill, right?
Yeah.
So that is a huge leverage, I think, which a lot of, I mean, my experience is almost nobody's using that today. And why? Because it's complicated somehow, right? You need to really understand the profile. And the other thing, you don't have the time, right? There's no task in Linear or Jira that said, hey, optimize the CPU, because most people don't even measure it these days, right? It was different 20 years ago because you had so much limitations on CPU and memory. But today, you almost have unlimited CPU and memory. You just have to pay for it. And so people just don't put too much effort into it, right? Which is kind of sad, right? Because I think we spend so much CPU cycles and RAM on unoptimized code. And that's a huge opportunity. I think that's something that got me excited with AI. And I think you released a feature recently, which, I mean, yes, humans and developers don't have the time, but why not using AI to do that for you and even suggest PRs, how to optimize your code to save a lot of money, right? And you told me that even on your own database, the AI found optimization potential right away.
Yeah, you're right. Like it's very often it's not that people don't even know that there's optimization potential. People just didn't get to it, right? I think that is almost the good case already, right? I think what you said earlier, we found this all the time with our customers that people have literally never seen this data on their across their entire infrastructure, right? So like even really performance conscious customers, and we have a really cool case study with Materialize. This is a high performance database. Literally, their customers choose this database because it's high performance, right? Within hours of deploying our product, they cut their AWS bill by 35%. 35%.
Yeah, it's
like
crazy,
for
right?
a company that's already obsessed with performance, right? That's not to say that they did anything bad. They've never seen this kind of data, right? And so like how do you know what to optimize if you've never seen this kind of data? At best, what sometimes people do is exactly the thing that you said, which is like on-demand profiling, right? You maybe look at a single process for a 10-second period or something, and you, well, by definition, can only see what happens during those 10 seconds, right? You don't see what happens repeatedly across your entire infrastructure all the time, right? And so that's where continuous profiling really, really shines.
That's maybe important to repeat, right? That continuous profiling means it's an always on profiling, right? You can turn it on in production, under load, under high
Yeah.
load, and have it run all the time, right?
Yeah.
That's kind of the power of it, because the way you explained, you do it right on eBPF. You just inject it, so it's very low interference, very low overhead, and you can do that continuously all the time.
Yeah, exactly. The profiler was specifically engineered so that this is okay to do in production. And so what's really exciting is that this overhead was able to go down to less than 1% for CPU profiling, which, is for the large majority of customers noise, right? Like you literally can't tell if it's on or off.
No, that makes sense. And so why do you think nobody's using it? What's your theory? I mean, nobody, but if I look into our customer base, like we have 800 customers. I know of 2 using you as a profiler, right?
Yeah.
In that base. I don't know if they use other profilers out there, but I think it's a very low number of customers who are actually really using it always in production, right? Where we just, I mean, I totally agree with you. It's one of the most powerful things, right? It reduces the overhead. It makes things faster, more robust. So it makes a ton of sense. But kind of, I don't know why is that? I don't know. Even when I was a developer, I was a profiling trainer. I used profiling very rarely, right? I don't know, timing issue or.
I think there are a couple of things, right? Like one, I think it just gets a bad rep, right? Like I think it's always been viewed as this, maybe the most senior engineer on the team has maybe had some experience with this at some point. It's kind of these scary visualizations that I have no idea how to read, right? At the end of the day, it's not really all that complicated, right? Like you figure out what is the function that uses the most, you look at the code path, can we avoid doing this code path, right? Like, or can we do it in batches? Like performance engineering is not terribly complicated. And so in that sense, I'm not sure why it hasn't taken off, because I it's not terribly complicated to do, I think. But certainly the tooling has always been a big part, right? Like you said that this is something you kind of associate with profiling, that it has high overhead. This is still a pretty
Yeah.
new thing, right?
Yeah.
Like continuous profiling is still very, very new. The like very first white paper that Google published around this was in the early 2010s, right? Like before that, nobody has ever talked about this concept of profiling in production. It was totally crazy to everyone, right? Now, I think it's becoming more normal that people have accepted that continuous profilers exist and that it's safe to do in production. But this connotation certainly still exists, and it still doesn't mean that people have taken the time to learn how to interpret this data, right? But it turns out, like you already said, and this kind of goes to the earlier point that I made as well, that profiling and performance engineering is really very systematic, And so it turns out that like AI coding agents are actually unbelievably good at it, right? Because it makes sense, right? Like they already understand and are pretty good at writing code, right? And it's incredibly systematic. You look at some data, and the data tells you this is the thing worth looking at. Well, then it explores this code path, and tries to optimize it. It's not rocket science, right? We've already seen quite an uptake in usage by organizations that also have less sophisticated engineering departments, and it's already been successful in that sense. So like I do believe that AI is a big enabler for this.
Yeah, and I can just imagine if you have an MCP server, which you have, and you connect your coding agent to it, that it will also do magic with it, right?
Yeah, exactly. Yeah,
It's the easiest way to do it, right? Just connect it, and then you have a new data source which the agent
exactly.
can use to optimize the code. And talking about AI, you also have GPU profiling, right? Tell me about that. What that means, and where does it help on training, inference? Where do you use GPU profiling?
Yeah, GPU profiling is of course really an exciting topic. First of all, GPU profilers basically don't exist. Like, we just talked about the absence of tooling. This is way worse in the GPU ecosystem. Like basically the only thing that exists is like NVIDIA Nsight. Like that's it. And that is like quite literally meant to only be used on your development machine, right? And so this landscape is totally untapped.
Which is kind of weird, right? Because we are spending hundreds of billions of dollars in the industry on GPUs. So
Exactly.
getting 5% optimization, which is, as we learned, not the biggest thing, translates into billions, right?
Billions, yes, it's a
Yeah.
completely crazy opportunity. That said, as we've learned, this is an unbelievably hard problem to solve. Um, Specifically because AI has been deeply like it very deeply depends on hardware, right? Like it's no secret that Nvidia is a really important player in this. And so you need to deeply understand how the Nvidia hardware works, how the APIs interacting with it works, how the ecosystem works, to be able to build something like this. The use cases are ultimately the same as for any other performance optimization work. You mentioned training, you mentioned inference. Ultimately, it's useful for both of those cases. I think it's a very different motivation typically why customers may want to use a profiler in each of those cases. I think with inference, it's quite simple. Exactly the things we talked about earlier. You improve tokens per second being served, and you reduce the cost of actually serving this model. I think it's pretty simple. I think for model training, this is a little bit different. Certainly, cost is an aspect, but I think the far bigger motivation for these companies is the ability to iterate faster than their competition. You mentioned cost, right? I think for a big portion of AI companies, staying ahead is worth way more than they're spending on GPUs at the moment. Maybe there'll be a time where this kind of shifts, but I don't think we've reached that time yet.
The profiling for GPUs works for NVIDIA chips.
Yes.
So that's the CUDA architecture, right?
Correct.
So essentially, you have used eBPF to figure out what the call stacks look like for this to be able to profile the GPUs.
Yes, exactly. Ultimately, it's a kind of a two-step process. So like we figure out what was the function call stack on the CPU that ended up calling this CUDA kernel. And then what actually happens within the CUDA kernel. And interestingly, CUDA in particular with NVIDIA, and this is more maybe even a general GPU kind of execution model. They work differently from CPUs, where they work in these essentially in groups of threads is kind of how you can think of it. And all these threads kind of execute the same thing in the cycles, right? So like if we think of a CPU core and one cycle, it can execute X instructions. And so with GPUs, it's these groups of threads that all execute kind of synchronously. I believe it's 32 threads, but I'm not 100% sure. I think that's what it is. And the problem is if there's one thread here, that needs longer to process some task, then all the other threads are stalled on that one completing. Okay. And so this is what's called a stall reason with NVIDIA hardware. And this is actually one of the most important things to understand. It's more important to understand why is my hardware not being fully utilized than, where can I, do an allocation less or something like that. That's a classic one for CPU optimizing. And so that was one of the key things that we needed to figure out. How can we figure out, the stall reason of why is my NVIDIA hardware not making as much progress as it possibly could? But then also the classic things, what is the CUDA function that's being executed? What's the instruction pointer? So that we can figure out, the exact line number that was executing at the time.
Exciting. So that means we will, in the next few months, release continuous profiling based on polar signals inside of Dash0 to all of our customers, which allow them to fully analyze their applications in production and do GPU analysis if they want, right, on inference, etc. Plus, we want to integrate that into Agent Zero, which will help you to automatically do the PRs for improvement of your infrastructure. I don't say the timeline, but we want to get Great Lakes, the database that you mentioned, as the new backend of Dash0, which will enable higher scale, better performance, and more cost optimized production for us. So super exciting. Frederic, again, welcome with your team to Dash0. I'm really looking forward to be working with you and get this out in production.
Yeah, let's do it.
Thanks for listening. I'm always sharing new insights and insider knowledge about observability on LinkedIn. You can follow me there for more. The podcast is produced by Dash0. We make observability easy for every developer.